All right, let's just jump right in. For the first time, well, ever in recorded history, something has entered our solar system that is fundamentally challenging everything we thought we knew about astrophysics. The universe has basically tossed a shimmering riddle into our backyard, and it's forcing us to ask a question that, until now, has really just been for science fiction. And this, right here, is the heart of the whole thing. This isn't just another weird comet or a funky asteroid. No, the data we're getting back is so strange and so consistent that it has literally drawn a battle line down the middle of the scientific community. And here's the wild part. Either path we go down, it leads to a complete revolution in how we see ourselves and the universe. And that quote from Michio Kaku, it just hits the nail on the head. We're not talking about one weird reading that can be dismissed. This is a cascade of them. It's a pattern of impossibility that is screaming out for a profound answer. So you're probably asking, what makes this thing a scientific earthquake? Well, as Kaku said, it's not one anomaly, it's 9 of them. So let's break down the key observations that just do not fit with anything we know. Okay, let's just run through some of the wildest ones on this list. First off, non-gravitational acceleration. Something besides the sun's gravity is pushing it. Now, for a comet, that'd be ice melting and shooting off gas, right? But we've detected 0 water signature, none. And speaking of comets, it has this bizarre anti-tail that points towards the sun. That's the complete opposite of how they're supposed to work. Then there's what it's made of. It's unusually heavy in nickel, which is not what we see in our local space rocks. On top of all that, you have rhythmic energy pulses, heat emissions that look like they're being managed, and a deceleration pattern as it's leaving that looks, well, controlled. You see, these aren't just little quirks. These are 9 separate glaring violations of the rules. So, when you've got this pile of weirdness, how do you even begin to interpret it? Well, it's kicked off one of the most important scientific debates of our lifetime, pitting that rigorous, healthy skepticism against what you might call intellectual courage. And to really get this debate, we need to understand this key term, technosignature. Now, we're not talking about little green men or UFOs from the movies. We are talking about measurable scientific data, things like waste heat, weird materials, or controlled motion that could be the fingerprint of engineering. And this slide lays out the 2 sides of the argument perfectly. On one hand, you've got the skeptics who say, hey, strange things just mean we don't know enough yet. On the other side, you've got this argument that when every single natural explanation you throw at it fails, well then refusing to even consider technology becomes its own kind of blind spot. Neil deGrasse Tyson is kind of the perfect voice for that healthy skepticism. He's not just denying the data, he's demanding a super high bar for the evidence. But what's so telling is that even he admits that the normal natural explanations for 3I Atlas are getting, as he puts it, strained. And then boom, you get the counterpoint from Harvard's Avi Loeb. His whole argument is that science is supposed to be about chasing the evidence, even if it leads you somewhere that feels uncomfortable. For him, ducking the technology question isn't good science. It's a failure of curiosity. But how do you keep yourself from just seeing aliens in every weird blip in the sky? Well, the legendary SETI pioneer Jill Tarter actually laid out this framework. It's a rigorous process. You don't get excited about a single blip. The reason 3I Atlas is being taken so seriously is that it's clearing these hurdles. It's hitting steps 2 and 3 because its anomalies are coherent, they're repeating, and we're seeing them across different kinds of observation. So, what's the game changer? What would be the smoking gun that ends the debate? While scientists are looking for signs of intent. Nature is messy, technology is controlled. So they're looking for things like a sudden course correction, or if its chaotic tumble suddenly stabilizes. Or what if the random radio noise it's emitting suddenly resolves into a pattern? Any of these things would be the kind of concrete data that could flip the switch. Okay, so let's take a deep breath and imagine for a second that it is an artifact. The second that's confirmed, the whole game changes. The question stops being a scientific one and becomes a profoundly human one. What on earth do we do? And who gets to decide? I mean, really think about that. This isn't about physics anymore. It's about politics and philosophy and our identity. One nation can't claim this. One leader can't speak for 7 billion of us. So who could possibly carry that kind of weight? And the ideas people are putting out there are just fascinating. Some, like Avi Loeb, say it has to be a team of scientists, people driven by reason. Then you have someone like astronaut Chris Hadfield, who suggests it needs to be someone who's seen the Earth from space, someone who has felt that sense of global unity. And then, of course, You've got the diplomatic approach.
And this insight from the late Madeleine Albright just cuts right to the heart of the challenge. The biggest danger probably isn't the visitor, it's us. It's our own tribal instincts. Fear could make us do something stupid. Her point was that whatever we do next, it has to be as a united species, not a bunch of squabbling tribes.
And if we do decide to speak up, what do we say? This question is incredible because it forces us to boil down the essence of who we are. What is the single most important thing a cosmic neighbor should know about us? And the suggestions here really say so much about us. Do we go with a simple, cooperative hello, or an honest admission of our flaws and our hopes? Maybe we just ask a question to start a dialogue. Or maybe we aim for something poetic, something universal about our shared origins, or just a simple, powerful declaration. We choose peace. Each one shows a different side of who we are. You know, in a way, it almost doesn't matter if it's natural or artificial. Just by showing up, this object is already acting like a giant mirror. It's forcing us all to zoom out and seriously rethink our place in the grand scheme of things. This idea from physicist Paul Davies, wow, it just stops you in your tracks. For all of human history, we've thought of ourselves as the main characters. But what if it turns out we're not the whole book? What if we're just one chapter in a much, much older story about intelligence in the cosmos? I absolutely love this metaphor from Priyamvada Natarajan. It completely reframes the search. The universe isn't empty, it's a library full of stories. And 3i Atlas, it might just be the first book from that library that's ever been dropped on our doorstep. So the real question is, are we mature enough to open it? And this really boils it all down to the final stakes. If it's a natural thing doing all this, it means the universe is far more creative and complex than we ever dreamed, and our physics books are wrong. That's a revolution in science. But if it's artificial, well, that's a revolution in our identity. It means we are not alone, and maybe we never have been. In the end, Michio Kaku brings it all right back home. It almost doesn't matter what 3i Atlas is. What truly matters is what it's asking of us. It's an invitation from the cosmos to grow up, to expand our minds, and to become a more mature species. So, as the object continues on its path and our telescopes stay glued to it, the real story isn't just happening out there in the dark. It's happening right here, in our labs, in our governments, and in our own minds. The universe has put a shimmering question mark in our sky, and now all of us, together, have to figure out how we're going to answer.